Now let's discuss about polygons. A polygon is a simple plane figure enclosed by line segment is called a polygon. Now let's discuss about some features of polygons. Firstly, a polygon is a simple plane figure, then it is a 2D shape and it is a closed figure. And the rest of the video will be continued by Shobhagya Vishwas and Rupayan Ghosh. Myself Shayan Datta this side, signing off. Thank you, thank you.
Hello everyone, myself Shobhagya Vishwas. Welcome to another video. Earlier we have already discussed about what are polygons. And today I am going to explain you about the four-sided polygon which is known as quadrilateral. So quadrilateral is nothing but a plain and simple closed figure made up of four line segments. Let us see that how many types of quadrilaterals are there. Now in this slide you can see the image of different types of quadrilaterals. At number 1 you can see the image of trapezium, and in number 2 there is a parallelogram followed by a rectangle at number 3. In number 4 there is an image of a rhombus, and finally the square. So I'm gonna basically focus on the parallelogram, and the other types of quadrilateral will be explained by Rupa and Ghosh in our upcoming videos. Now let us understand the different properties of parallelogram. At first let us see what the theorem 1 says. The diagonals of a parallelogram divides it into two congruent triangles. So here we have taken a parallelogram ABCD. Here we can see two triangles. One is ABD and another is BDC. So here BD is the diagonal and it is bisecting the parallelogram into two triangles ABD and BDC. Here we can see that angle B, this one, and angle D, this one, is equal due to alternate interior angles, and this angle is equal due to alternate interior angles as AB parallel to DC here, and BD is the common side here. Thus we can prove by ASA criterion that triangle ABD is congruent to triangle BDC. The second theorem is, in a parallelogram the opposite sides are equal, and the third theorem is exactly the converse of it, that is, if the each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So here we can see that the line segment AD and PC are equal to one another, and the side AB and DC are equal to one another. Thus our theorem 3 and theorem 4 is proved. Now let us see theorem 3 and theorem 4. In theorem 3 we see that in a parallelogram the opposite angles are equal, and theorem 4 is exactly converse of it, that in a quadrilateral if each pair of opposite angles are equal, then it is a parallelogram. Here you can see in this parallelogram that angle DAB is equal to angle DCB and angle ADC is equal to angle ABC. Thus our theorem 3 and 4 is proved that opposite angles of a parallelogram are equal. Now let us see the theorem 6 and theorem 7. In theorem 6 we see that the diagonals of a parallelogram bisect each other, and in theorem 7 is exactly the converse of it, that if in a quadrilateral the diagonals bisect each other, then it is a parallelogram. So here in the parallelogram ABCD you can see that the diagonals AC and BD intersect each other at point O, and Here it is shown that AO is equal to OC and OB is equal to OD. Thus, our theorem 6 and theorem 7 is proved that the diagonals of a parallelogram bisect each other. So, this was all about the properties of parallelogram that we have discussed till now. From our next video, we will discuss about the characteristics of other types of quadrilaterals. So, till then, stay connected, keep learning. Thank you very much.
Previously, we have discussed about parallelogram, and now myself Rupan was discussing about rhombus. Rhombus is a four-sided polygon with all sides of equal length. All angles are equal and the diagonal bisect each other at 90 degrees. Now rectangle. Rectangle is a four-sided polygon with opposite sides having equal length and four right angles. It is also a type of quadrilateral. Now square. Square is a four-sided polygon with all sides equal and all angles 90 degree. Diagonals are equal and diagonal bisect each other at 90 degree. The diagonal also act as an angular bisector.